Hello and welcome to Monday's edition of Cracking the Cryptic. I hope you've been really enjoying the content over the last week or two. The sequence of puzzles has been quite extraordinary, and these are the sorts of sequences that we like to continue. So today I have a puzzle by one of the new geniuses on the world Sudoku scene, Qodec. He calls this one eddies, apparently, because these circles, I think, reminded him of eddies in a river. I don't think there's any hidden message there. I think we just have to take it on trust, and that's what he's thinking. So we're going to have a look at this. I believe it's quite difficult. When is it not? But before we get started, Reverend's Puzzle Hunt, which is available to those of you who are patrons of the channel over on Patreon. We've got more correct solutions received overnight. So I want to say well done to Mirko Schultz, the Cortez family, Algriff, Sina and Lucas, Doug Limmer, Toby Williams, Mike Walsh, Juniper Skunk Tour, Daniel Massey, Doug Jones, Tristan Coe and Alvin Ding. Fantastic solving, all of you. Very well done. And if you haven't had a go at the puzzle hunt yet, definitely try it. It's pleasing a lot of people. Now, Qodec's new puzzle. Qodec, I mean, what an author this man is. He has been producing some absolute masterpieces. And yeah, I imagine this is going to be another one. Normal Sudoku rules apply. Digits along an arrow in the grid must sum to the digit in its circle. So if you've not seen Arrow Sudoku before, let's just do a quick refresher on what that means. Those two cells, whatever these two cells sum to, must appear in the arrow. So if that was a 2 and that was a 3, this would have to be a 5. That's how that works. Digits may repeat along an arrow as well, but obviously not along that arrow because that will break the rules of normal Sudoku. So that arrow, for example, could have a 1 in those two positions. That would be fine. Cells with a grey circle must be odd. So that's these. The eddies are odd. And cells with a grey square must be even. So we've got 4 grey squares as well. And that's it. So do have a go. The way to play, of course, is to click the link under the video. Now I get to play. Let's get cracking. So, what can we see at the start of this puzzle? The first place my eyes are drawn, and I might be peculiar in this regard, I do not know, but this pattern of arrows around the central box is intriguing to me, because yeah, this is deliberate. I'm sure it's deliberate. Let us think about what this means. What is the sum of these 3 cells? Now, if I knew that exactly, I'd be doing very well. I do not know it exactly, but I know it has a characteristic. I know it must be even, because whether there's an odd number or an even number in the circle, because we're doubling the odd number or doubling the even number in calculating the value of all 3 squares, I know that the combination of these 3 squares is even. Now, if these are even, and these are even, we know something about a whole row or a whole column of a Sudoku. A whole row or column adds to 45 because it contains all of the digits 1 to 9. So if I know that the yellow cells are adding to even totals, but the whole column, for example, is odd, these 3 squares have got to be odd. And these 3 squares have got to be odd. But look at this. The eddies are odd numbers. So we can't put 3 odd numbers in a row to make these 3 cells odd. In fact, there's only 1 odd number available in this run of digits. So there must be 1 odd number in this run of digits to create an overall odd number for the column. There must be 1 odd number in these 3 cells to make this row odd overall. So the only place I can put the 5th odd number in this box is in the centre. So this square is odd. Now, unfortunately, I'm just realising I do not have the ability to draw in a way, what I want to draw is another grey circle in the middle of the grid here. But I can't do that, so I think I will just shade that orange, if you don't mind. Orange for odd. O for orange, O for odd. That's the way I like to think about these things. Now, what does that mean? Absolutely nothing. I mean, this feels very like a setup, doesn't it? Maybe it's the evens I need to think about. So if these are even numbers, let's make them blue for even. Is this... no, that's not telling me anything. In fact, I don't even like the fact I've coloured it in. I don't think it's necessary. Right. No, I'm actually... this might be a total red herring then. I'm sorry. I think we're going to have to look at other things. I can't... or at least if there's something obvious that follows from this being odd, I have no idea what it is. So, let's look at other things. What else could we look at? Well, our favourite arrows trick is looking for... if you've got 3 cells along an arrow and they're all in the same box, row or column, you know they must be different digits. And that puts a bit of a restriction on the value in the circle, because the minimum I can make those 3 squares would be 1, 2 and 3. So the minimum I can make this square is 6. We've got another one of those there. We've got a little short stubby arrow here. So this one's just saying these 2 cells are the same. That's very unlikely to be useful at this point. This one, rather annoyingly, bends. So I can't assume this one is 6 or higher, because we could, for example, in fact this could be as low as 4. If we went double 1 there, we can't go double, I can't make this square 1, but I can do it like that. Have the 1s repeating there. And this square would be a 4, so that's this one's under much less pressure. We've got 4 circles in row 3. But again, I mean, I could be missing something here, but if you look at the arrows emanating from all of these circles, they're all 2-cell arrows, which in theory, you know, that could be a 1 and a 2. If that's a 1 and a 2, this is a 3. So it's not really like I'm likely to get some sort of quadruple in these circles. This is strange, actually. This is not... it's not proving terribly pliable at this moment, is it? So what is it? If we can't use... if I can't use arrows... and I can't use odds and evens, and I've got no given digits. Right, well, you can't put 1s in circles, okay, or 2s, unless it's this circle. So, no, that's not the way to look at this. You can't put 9s on arrows. 9. This row. This row might be interesting, because I can't put 9 on an arrow, because then the circle would have to be at least equal to 10. So a 9 is not an even number, last time I checked. So 9 is not in any of... so 9's in one of 3 positions in... I'll just pencil that for a minute. 9's in one of 3 positions in row 2, and... let's be very careful about this, because... so 9 in row 5... 9 can't go in the middle cell, because it's on an arrow. Right, sorry, look, 9 in the middle row is really restricted, because it can't go here, and it can't go in these 2 squares, because these 5 squares form the quintuple of the odd numbers. 9 in the middle row is definitely in one of those 2 positions. Oh no, they're not aligning. I thought we were going to find something like a swordfish on 9s in the grid. No, maybe we're not. So let's carry on, because I imagine this row is going to be restricted as well. 9 in... so 9 can't go on an arrow, 9 is not even. So these 3 squares can be 9s. Sorry, this must... Well, this felt like it was a really good idea. What is it I'm missing about this? I'm missing... I don't know what I'm missing. I'm missing... There's nothing there, is there? There is nothing there. I don't think there's anything there. Got the same restriction on 9s in column 5 though. Maybe it's not. Maybe it's not. Maybe it's... I'm just going to get rid of these 9s for a second, because what I'm noticing now is if I look at column 5, the 9s are restricted in an identical way to row 5. The only place 9s can go in column 5 is in one of those two places. So we've got this peculiar pattern of 9s. 9s in the columns? No, I mean 9s can go almost anywhere in column 1, I think. 6 different cells. 2. 9 can go in the circle, obviously. 4 cells, I think, in column 2. Basically the whole of column 3 apart from 2 little cells. Sorry, let me scan this for a second. Same pattern over there. So is this pattern? See, this is not a swordfish, is it? So what I'm looking at here is, if I look at the purples in the columns rather than the rows, you can see that if I didn't have these cells to deal with, I would have a pattern. Oh, I forgot to put my phone on silent. I must do that, otherwise it's likely to go WhatsApp crazy. Yeah, if these cells weren't purple, oh, I see. Good grief. This is beautiful, actually. This is I mean, don't get me wrong. Do not get me wrong. I'm not on my way to a digit here, but I have seen something interesting. This is really very cool. So, good Lord. Now, in row 5, 9 is either here or here. Now, whichever one of these it's in, it is going to remove the purple possibilities from its box. So imagine this was a 9, just for the sake of exposition. Once this is a 9, where can the 9 now go in column 8? It can't go in those cells anymore. Now look what that's created though. That has created an X-wing on 9s in columns 5 and 8, in the sense that if this is a 9, I now know that there's only 2 positions for a 9 in column 5, and it's these 2. There's only 2 positions for a 9 in column 8, and it's these 2. And so however the 9s are arranged in the finished solution, there'll either be 9s there, one limb of the X, or there'll be 9s here in the other limb of the X. But either way round, you won't be able to put 9s in any of the rest of the row. But this is rather beautiful, actually. This really is rather beautiful, because if this is not 9 and this is 9, we get exactly the same pattern on the other side of the grid. Now we've got 9s here, 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 and here. So the set effect is the same. We either get 9s on this diagonal, in which case we're eliminating 9s from all of these cells, or we get 9s into the other 2 positions, in which case we're eliminating 9s from basically the same set of cells. So what does this mean? it does affect some. It does affect some of the circles. That's what it means. So I've either got an X-wing this way round, or I've got an X-wing this way round. So yeah, for example, these two cells never can contain a 9. It's impossible. And in row 7, those two squares can't contain a 9. Now that is interesting immediately to me. Right, good grief. So I don't know if I'll be able to notate this when I edit the video, but if I can, I will. The key, I think, is to realise that we can't now put 9s in those squares. I'm actually going to notate, therefore, what they can be. The thing is, they can still be 3. Well, this one can't be 3, actually. That one, this one could still be 4. But it definitely can't be higher than 8. This one can't be higher than 8. I mean, as I say, this is not an amazing restriction, although I can see it's going to plonk 1 into one of those two squares in row 7, because once these two can't be 9s, you get an interesting feature of these totals, which is, of course, that now, if whether this is 6, 7 or 8, a 3-cell sum has got to contain a 1, because 8 will always need 1, 3, 4 or 1, 2, 5. You can't make 8 with 2, 3 and 4 because they add up to 9. Similarly here, there must be a 1 in these cells. So now we can ask the question, where does 1 go in row 7? It can't be in those squares, it can't be in those squares. It can't be in a circle because this is a sum of 2 digits, so the 1 is in one of those two positions. And that also, a bit like the start, that feels incredibly beautiful and deliberate. You see, and this is very suspicious now. This is so... I think I've missed something about this puzzle, because if the 1 in box 5 is in a circle, the 1 in box 2 goes on this arrow here, because it can't go in the circle, because you've got to place a 1 somewhere in column 5, and it would have to be in one of these two cells. And that's going to affect... Well, that means this arrow gets a lot larger, because you then can't put a 1 in any of those positions. So this would have to be... So is it... I'm now wondering if there's a way of eliminating 1 from this cell. And that would allow me to know the 1 was in one of... Well, because I know this is the set of 5 odd numbers. If this isn't a 1, we're in clover, aren't we? Actually, this 9 is not right. Obviously, that was just me showing the effect of one of these being a 9. I don't know that this is a 9 or not. One of these is 9. One of these is 9. One of these is 9. And one of these is 9. It's a sort of expand... It's such a weird pattern. If this is a 1, why does that break? Why does that break the puzzle? Does it break these arrows? No, it doesn't break the arrows. Does it break the maths? Okay. Actually, we can at least test the maths here, because obviously this column sums to 45, and this row sums to 45 because it's one complete row of the Sudoku, all of the digits 1 to 9. So the two together sum up to 90. But if I put a 1 in the middle, that means the rest of the digits have to sum up to 88 because the 1's been counted effectively. We're saying these squares sum to 44, these squares sum to 44. But I actually know the value of those 4 squares because they are either even digits in box 5, so they add up to 20. 2 plus 4 plus 6 plus 8 equals 20. So these cells add up to 68. Now hang on. This is really interesting because these are all, so each one of these, if the sum of this is 2x, but we know the sum of this will be 2x, the sum of this will be 2y, 2a, 2b, because whatever's in the circle is also the sum of the domino. So we can just divide this by 2. So the circled cells sum up to 60, what did I say it was? 68 divided by 2, 34. The circled cells sum to 34. How on earth do we do that? How on earth do you make those 4 squares sum to 34? You can't put, you've got to use 8s and 9s. It's got to be 8. It's got to be an 8 and a 9 in this column and an 8 and a 9 in this row. You can't put 9 and 9, for example. They're obviously going to clash. So you have to max these out. Now, why doesn't that work? The answer is if one of them's 8 and one of them's 9, and these are even digits. Oh no, I know why it doesn't work. Sorry, I know why it doesn't work. I am being very, very slow. The reason it doesn't work is if there is an 8-9 pair here and an 8-9 pair here, there is no 8 in any of those cells in the middle box. It's nothing to do with the sums round here. It's to do with the middle box. There can't be an 8 in the middle box at all because the circles are odd. So this is wrong. So there is no 1 here. So this, right, okay. So what we've discovered about the puzzle is that when I found that this was odd, I should also have thought about what it could be. And now I've done the thinking, and now I know what it can be. It can't be 1. So let us get rid of all this and get rid of 1 from here. This square here has got to not be 1, and it can't be 9 because it's on the arrow. So this is 3, 5, or 7. But more importantly than this being 3, 5, 7 is that the 1 in box 5 is in one of these squares. And that, look, is aligning rather beautifully with where the 1 is in box 8. Now we can ask the question, where does the 1 go in column 5? Well, it can't be in these 3. It can't be in these 3. It can't be in the circle. So it is in one of those 2. And now I'm expecting great things of this arrow because well, especially this arrow is now restricted. This square is 2 at minimum. This square is even, so it's 2 or 4. Right, this square can never be 7. I could have spotted that immediately, actually, because obviously... Oh, no, no, it can't be 7 because you can't put double 1 in here. And that would have been possible up until the point that we've just shown it's... Well, this is even for one thing, and we know that therefore it can't be 1. But now there's a 1 here, we know this can't be 1 either. This is not 7. So this is 3 or 5, and the minimum total we can get to here... Oh, in fact, 5... No, 5 doesn't work. Oh, this is absolutely beautiful. The fact that this can't be a 9... The fact this can't be a 9 because of the weird purple shape thing prevents this square from being a 5, because you've got 5, 2 and 2 would be the best you'd do, and that adds up to 9. So this is a 3. We've got a digit. And the same thing, this is so clever. This can't be 4, because if this is 4 and this is 2, that still adds up to 9, which is still impossible. This is 2. 3, 2. So we're looking at 7 or 8 into this square, which means this square is a 2 or a 3. Now, what does this mean? It means, I don't know what it means. It means there's a bit of a restriction on these squares, I suppose. It doesn't look amazing though. Oh, come on. Getting digits is a luxury in this puzzle. 2, 3. Oh, I know what it means. It's something simple. I've got 1, 2 and 3 in column 5. This is a 2-cell arrow. Well, it can't contain 1, 2 and 3, so it must contain 4 and 5, and this must be a 9, which means that's not 9. That means that 9 is very restricted in box 7, look, because 9 can't go in these squares now by Sudoku. It's not even. It can't ever go on an arrow, so it's locked into one of 2 places in box 7. 9 in box 9 is not there, not here. It's not even. It's not on an arrow. We get a digit. 9 is there. Oh, and this is lovely. This 9 is seeing this square. Now, how many positions for 9s were there in row 5? 2. This one and this one. Now, this one can't be a 9. So the 9 must go there, which fixes the 9 in box 7 immediately. 9. Yeah, and look, 9 now in box 1 can't be on an arrow. It's not even. It goes here. 9 in box 2 can't be on an arrow and can't be in that square, so it's in one of 2 places. 9 in box 3 is in one of 2 places. So 9 in not quite. 9 in box 6 is in one of 2 places, I think. And 9 in box 5 is also in one of 2 places because it must be. Yeah, it must be on a circle, so it's got to be in one of these 2 cells. Wow. Okay, well that felt like proper progress at last, didn't it? What does it mean? Then sorry, I don't know what it means at all. Apologies if you're spotting something immediately here. I have not. I'm actually a bit nonplussed by that. That flurry of 9s I thought would be immediately useful, but has it actually done anything for me? Maybe it's this arrow. 2, 3, 4, 5. Yeah, okay. This arrow is a bit restricted because what can I join the 1 up with? The minimum I could join the 1 up with would be a 6. So if that's 1, 6, this would be 7. If this is 1, 7, this would be 8. And it can't be 1, 8 because you can't make this 9. That gives a 7, 8 pair in row 3, which removes 7 and 8 from that one. Six, 7, 8. 8. So this square has to be even. and its options are from 1, 6, 7 and 8. So this is a 6 or an 8, I think. So there's definitely a 7 in this string of digits, but we could still put it in the arrow, so we don't know where it goes. So this arrow now can't be 7 or 8. Oh, beautiful. I've got another idea. 1. Where does 1 go in box 1? The answer is I have no idea. I've got no clue where it goes, except it's not in those 3 squares. So it's aligning with the ones I've got in box 2. So the 1 is in one of these positions. Now that's going to matter, because this arrow has been restricted. Because now this arrow, well, the minimum I could make those squares, given I can't use 1, is a 2 and a 3, which is 5. But the maximum I can make them is 6. So this is a 5 or a 6. So this is either 2, 3 or 2, 4. It definitely has a 2 in it. I love this puzzle. I love this puzzle. Look, the 2's now align. Again, let's look back at box 1. Where does the 2 go? I still haven't got a Scooby-Doo, but it's in one of these 6 cells. So the 2's now align in boxes 1 and 3, which means the 2 in box 2 here can't be in these cells. It must be in one of those 2 cells. Now that might restrict this arrow. Yeah, this... So this arrow now cannot contain a 1 and cannot contain a 2. So it's either, if it's 7, it's 3, 4. And if it's 8, it's 3, 5. So it definitely... Oh, this is it. This is unbelievable setting. Unbelievably good. So now I know for sure there is a 3 in this domino. And this 3 in the domino here, because to make this total I need to use the 3, fixes that this is a 2. Now that fixes this sum as 7, which means that's a 7. This is an 8, which means this is now a 1, 7 pair. This means I need 3, 4 into here. And I'm sure that this is useful. Let me just work out why. This 8 fixes it. We get 6 in box 5. 3, 4. What else does it do? I'm sure it does something else. These squares now have got to be 5, 6 or 9. That's not 9. 5, 6 pair in the row. 5, 6 pair in the row fixes a bit of that one. So this arrow is now a 3, 4 arrow, which means it has got a 1 on it for certain. This is either 1 and 2 or 1 and 3. Does that do something for me? I don't know. I can't see what it does. These squares are 1, 3 and 4. So let's just step through what we just got and just try and work out what it means. We've got a 2 in these squares now, which means there's a 2 in one of those. Oh, now hang on. We've got a 5 in one of these squares. That means in the central box, the places for the odd digits are on the circles. So this is a 5, 9 pair. So we can get rid of the 1, 9 pencil mark. Now that, unless I've made a mistake, that means these squares are now 1 and 7. Yeah, okay, I can believe that. That doesn't look wrong, does it? 1 and 7. So I've not placed 4 and 8 in this box. Now the 4 is here, so there's a 4 there, and then 8 here. This 1 means that square's a 1 by Sudoku. This triple is now known in theory. It's got to be 2, 3, and 8. This triple or pair is 6 and 7. And did we get anything else from this? 7 here. Oh well, a little bit. 7 in box 7. Where does it go? It's not even. It can't go on the arrow because this, well, it just can't go on the arrow clearly. It would make it far too large. So 7 is in one of those 2 cells. Okay, it's maybe not as good as I was hoping. 7 in box 9. We can remove 7 from that cell, this cell here. So actually 7 can't... Oh, in fact, look, 7, where does 7 go in box 9? It's not even, it can't go on the arrow, and there's only 1 space left, so 7 is actually now placed. Oh, lovely, look, 7 in now... This box at the top is not in those squares, it's not even, so its only positions are in the same cells as the 9, so there's a 7-9 pair here. Now, can we put 7 on this arrow? That's an interesting question. If 7 was on the arrow, this would have to be 8 or 9, so no, we can't. So there's also a 7-9 pair in this box. In fact, what can we put on this arrow? Or a better question is, how do we make this arrow add up to 9? Because we can't use 1, 8, 3, 6 or 4, 5. This is a 2-7 pair, I think. I was about to say 7s are aligning, and they are aligning, but we've already got the 7 in box 1, so that is not a helpful alignment. 2s, are they aligning with anything? I wouldn't put it past this puzzle, I really wouldn't. So we've now got 1... so this triple is 1, 5 and 6, but we know that 1 digit is the sum of the other 2. That's not terribly difficult to work out. We've got a 6 here and a 1, 5 here. So 6, look, in box 3 has to be in one of those 2 positions. Whoopsie. And 6... That's interesting, because now where are we going to put 6 in box 9 of the grid? 6 cannot go on the arrow, because I can't put double 1 along with it to make 8. So 6 is in the arrow, which means the arrow is a 1, 2, 3 triple. The 1s are aligning. Now, look, this puzzle is extraordinary. I mean, Qodec, my goodness. This is extraordinary, this puzzle. 1's here, 1's here. So where's the 1 go in this column? Well, it can't go in those 6 cells. So it must be there, because we know it's in one of these 2 positions in box 3. So that is now a 1. We get rid of the 1 from that cell. There's a 2, 3, 4 triple now. I suppose there was a 1, 2, 3, 4 quadruple before. Now, what have we got left to place? 5, 6 and 8 into these squares. That means that... What does that mean? Don't know. I've got... Do I learn anything about... I don't learn anything about what this can be, I don't think. It's going to be very easy for me to miss all sorts of things in this puzzle, though. There is a lot going on. 9. So, have I got anything going on? This box is restricted now. I've got 1, 2, 3, 6, 7 and 9. So I need 4, 5 and 8. Look. Yeah, okay. I need 4, 5 and 8 into these squares. But I can't put 5 in the even square. So 5 is definitely in one of those two squares. There's a 4, 8 here. Right, okay, there is a nasty quadruple there. 4, 5, 6 and 8 in column 8. That's nice because it fixes that cell. That can't be 5, it must be 1. This must be 5. That means this square is not 1. 4, 5, 6 and 8. This square can't be 4. 2, 3. Oh, close. I've had 40 minutes on this puzzle. If you'd have said it was 15 minutes, I'd have said, yeah, that sounds about right. It's just flown past. 4, 5, 6, 8 quadruple. That's given me a 5 here. It's not good, is it? It's not quite revealing secrets. Right, 6 here is removing 6 from that square. So this is 7 or 8. Still, this. Sorry, I'm stuck. Is it the little arrow? We can do something with that, maybe. Not. So this square here, it can be 2, 3, 4. Can't be 5. 6. It can't be 6. We've got a 6 over here. 7 or 8. Oh, it can't be 7 either, actually. 7, 2, 3, 4, or 8. It can't be 2 because there's a 2 in this box, and obviously whatever I put in this cell is repeated here. So it's 3, 4, or 8. Let's put it in here and see if we can get rid of something else. So 3, 4, or 8. Can anyone see what to do? There's a trick you can do with the 8 now. Well, it's not a trick, but now there must be a 2 on the arrow. Oh, right, okay, let's actually look at this. So if this was an 8, now what are the options left for this 3-cell arrow? Well, one option is 1, 2, 5, and in fact that would be the option it would have to be, because if this was 1, 3, 4, this cell would have no value. So this is interesting actually, because that means that whatever this square is, if it's a 7, we know this is 1, 2, 4. If it's an 8, it's 1, 2, 5, so there is now always a 2. There is always a 2. Why does that matter? There's always a 2. So does that affect this one? So this square now is 4, 6, or 8. There's a little, sorry, I've just spotted, look, we've got an alignment of 2s in boxes 7 and 9. The 2s are locked into the bottom 2 rows. So where does 2 go in row 7 of the grid? It can't go in those 3 or those 3, so it can only go there. That locks 8. No, more important, it locks 3 downwards. So 3 now aligned. Is this puzzle, if this is how you're meant to solve it, is quite incredible. It's incredible because now look, 3s are now aligned in rows 8 and 9. So again, the question now is, where does 3 go in row 7? It's got to be in one of those 2 squares. It feels deliberate. All of these little intricate workings of the puzzle feel like what Qodec meant us to find. It's so clever. You see, now look as well, now this can't be a 3, because whichever one of these is a 3, If this is a 3, obviously it's very easy to see this isn't a 3. But if that's a 3, it gets reflected into the circle, and it still can't be a 3. In fact, this is another way of saying the 3 in column 2 has to be in this domino. And I have no way of notating that in a way that won't make me weep later. So I'm just going to get rid of the 3 from there. Now if I can get rid of the 3 from here, we are good to go, aren't we? Why can't this be a 3? If this is a 3, that's a 4. That's a 3, that's a 4, that's a 2. Right, okay, this can't be a 3. This can't be a 3. I think it breaks this arrow. I think it forces this to be a 4. Or it forces double 2 here. Yeah, if this is a 3, you get a 3 there. And now I can't put 3 onto this arrow. So the only option left for this arrow is 2 and 4. But because this is a 3, this is now a 4, and I can't put 4 there either. So this arrow has no solution. So this is not 3. And again, it must be this whole sequence down here. Firstly, let me just think about this again, because I just want to admire it. Firstly, this arrow, it was this one cell arrow forcing this to be 3, 4, or 8, allowed me to conclude there was a 2 on this arrow, allowed me to conclude there was a 3 down here, aligning here, allowed me to conclude there was a 3 in one of these two, eliminating the 3 from this square, which makes you think about whether this square can be a 3, which finally reveals it can't be. You can eliminate 3 from both these cells. This square is a 3. It's quite unbelievable, this. This is unbelievable setting. Now, please get me more than just a 4. No, come on. So 4 must be in one of these two positions. 4 is not here. 4 is in this domino. No, 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 no. Come on. Come on. 6 is not there. What on earth? You see, the other thing about this sort of puzzle is it gets your respect. I mean, I'm convinced the fact I've got this 3 here and this 4 here must do something for him. Or maybe it's the fact I've got a 1-2 pair. Oh, it is. It's the fact that there's a 2 in one of these two squares, and there's a 2 in one of these two squares. So again, we've got alignment. The 2 in column 3 now, where does it go? It can't go here. It can't go here. We know that the 2 in box 7 is on the arrow, and the only cell available that's in column 3 is that one. This is a 2. These squares are now either 1, 4 or 1, 5. This is now not a 2. So the 2 is down there. Now, what has this done for us? Have we now figured out the puzzle? That's the question. Oh, I know what it's done for us. I'm being so slow. I'm so sorry. This 4, it's got rid of a 4 from this arrow. So this square's a 5. That gives me a 6 here. Now here we go again. Let's go now. So now we can get rid of 5 from that, which I could have done a while ago. This square is now an 8. This is a 6. 8 must be in one of those two cells in box 1. This square is a 5. Eight's in one of those two cells in box 6. 6, 2. So I've got a 2, 3 pair, I've got a 4, 8 pair, I've got a 7, 9 pair. Now, 6 has to be in one of those two positions. That means I don't know what it means. I don't know what it means. Why, puzzle, do you resist me so? Okay, come on. What is it that we're meant to spot next? We can... Can I do anything with all these pairs down here? I've probably missed like a really obvious deduction, knowing me. No, I can't see how to do that. This square, I know there's a 2 in here. Ah, right, this can only be 4 or 8. Can't be 6, can't be 2. This one is 4, 6 or 8. This row two here, 2 here. No, I've done the 2s. Don't think about 2s anymore. 8 here would force 7 here. Oh, right, okay. Here's something. If this is 8, you've got a problem in this box. Because if this is 8, where does the 4 go in row 7? It's got to go in one of these two squares. But the moment you make this 8 and this 7, you need a 4 in order for this to be 1, 4, 2. So if you make this 8, you need 2 4s in box 7 of the grid. So that's 4, that's 8. That's 8, that's 3. Lovely. This 3 gives us a 1. That fixes a 1 here. That fixes a 1 up the top of the grid. We get the 1 and the 2. This 2 gives us a 2 and a 7. This 7, oh, this is going all over the grid. This 7 fixes the 7 into this square, which gives us a 4 here. This is now not 4. In fact, we get the 4 and the 5 resolved. The 6 is resolved by the 8 here. The 6 and the 7 get resolved. This is not 4 anymore. This is a 3, 8 pair. Oh, but okay. Oh no, these are mirroring each other, aren't they? So this square should be a 5. That looks good. This can be a 5 without me breaking anything, I think. This square can't be a 4 anymore because it's reflecting whatever I put in this square. So the only... so this square's a 4. 4 and the 3 go in. The 3 and the 2 go in. And I think we must be closing in on a solution. Don't want to speak too soon though. I'm only too well aware it could all go wrong. In this column I need to put a 5 somewhere. So that 5 goes in there and we get a bit of traction from that. In fact, we get a lot of traction from that. Now 1 must go here by Sudoku. This 8 means that's an 8. That fixes the 8 and the 3. That fixes all of this stuff down here. Now this column, look, just needs 4 and 6. And there's a 4 there to help us. And we know the order. That becomes a 4 if I trust my pencil marks. This becomes a 6, 8 pair, which we can do. Yes, come on. 6, 8. This square should be a 5. That fixes the 5 and the 9. The 9 and the 7 go in. The 7 and the 1 go in. The 3 fixes the 3 and the 2. That should be a 3 by Sudoku. This square should be an 8. And hopefully this square is a 2. And that is as good a Sudoku as you will ever see in your life. I really hope I haven't messed that up. Let me click tick. Yes, I am really proud of that. I'm pleased I solved it because I think it's a really difficult puzzle. But my goodness, it's rewarding. There is some incredible logic in there. Incredible, Qodec. Incredible. Absolutely loved it. I'm sorry it took me a while. There were a few places I sort of boo-booed, but yeah, let me know in the comments how you found the puzzle, and we'll be back later with another edition of Cracking the Cryptic.